Hey guys, today we're going to do 6-2, which is all about kites and trapezoids, so it'll be super fun. We have three objectives today. We're going to learn about the properties of a kite. So we're going to look at the diagonals of a kite to solve problems. And then we're going to look at the properties of an isosceles trapezoid. So a trapezoid that has two sides that are equal in length. And then we're going to look at what we call the mid-segment theorem, and we're going to use that to solve problems. So we have four new vocabulary today. First, we're going to review what a trapezoid and a kite are. And then we're going to look at what is an isosceles trapezoid. And then our last new vocabulary is the mid-segment of a trapezoid. So what does that mean? And then our theorems and postulates, we're going to look at what are the properties of a kite, what are the properties of an isosceles trapezoid, and then our only theorem today is the trapezoid mid-segment theorem. So we're going to jump down to the end of our packet, and we are going to look at our new vocabulary. All right, so let's start here with trapezoid. So a trapezoid has four sides, okay, and all it means is that two of the sides, so in this case, the top and the bottom, are parallel to each other. Remember, that's why we have this little arrow, is that the top and the bottom are parallel. And what we do is we call the top and the bottom bases. Okay, so this is called a base, and this is called a base. And so we usually call them like base 1 and base 2, but it doesn't actually matter. I mean, this one could have been base 1 and this one could have been base 2. But just know that the two sides that are parallel are called bases, and then the other two sides are just called sides or legs. All right, so a kite, again, four sides. It's a quadrilateral, so four sides. Two pairs of equal side lengths. So the two shorter lengths of sides are congruent, and the two longer lengths are congruent. And we will talk about more properties of these here in a little bit, but just as your general shape. Okay, the next one is an isosceles trapezoid. And remember that isosceles just means two sides are the same length. Okay, so in an isosceles trapezoid, you still have to have your bases, right? Like B1, B2. But in an isosceles trapezoid, the two sides are the same length. And that's really important. And so then not only are the two sides the same length, but these two, what we call base angles, are the same length. And then these two upper base angles are also the same length. Okay, so there's some fun little properties going on there. Okay, but an isosceles, the only difference between an isosceles trapezoid and a regular trapezoid is that an isosceles trapezoid has this, the two legs are the same length. Okay, and then the last one we're going to go over today is the mid-segment of a trapezoid. So this is the segment that connects the midpoints of the legs. So here's a trapezoid. If I find the middle of line AB, here it is right here. Okay, and I know it's the middle because X to B is the same length as X to A. And then I find the middle of leg CD, which is Y, and again, I know it's the middle because of these tick marks, right? C to Y is the same length as D to Y. And then if I connect those, two, a couple really interesting things happen. One, this is called the mid-segment. It's the segment in the middle, okay? And also, it will also be parallel to both of the bases. So that's just a fun little property of the mid-segment of a trapezoid, is that it will also be parallel to the bases. So that's it for vocabulary. Let's keep going down and let's go back to our theorems and postulates. And here we have the trapezoid mid-segment theorem, which we're going to talk about right now. So it says the segment containing the midpoints of the two lengths. So here, X to Y is my mid-segment. So I'll try to draw that in. There we go. Okay, and it is parallel to the bases. Okay, it is parallel to the bases, and its length is half the sum of the lengths of the bases. So that seems a little like confusing, right? If I call this one, let's call this base 1 and base 2, and this is line M. Okay, so all this means is that if I take my first base, base 1, and I add it to my second base, which is base 2, and I divide it by 2. So I'm going to take the top length plus the bottom length, and I'm going to divide by 2. That will get me the length of the midsegment. And so that's something that we use quite a bit when we're solving problems, because it just helps us either find the length of the midsegment, or it helps us find the length of one of the bases if I do know the length of the midsegment. So that's our only theorem. The only other thing that we're going to look at is our properties of kites and trapezoids. So if you keep scrolling, the next page in your packet is all about the different properties of kites and trapezoids. So here we have the definition of a kite, right? A kite is a quadrilateral with two pairs of adjacent sides congruent. So that's meaning, right, AB and AD are the same. I'll put that in there. And BC and DC are the same. No pairs of opposite sides are congruent, right? So the opposite sides are not congruent. Exactly one diagonal is the perpendicular bisector of the other. So I'm going to underline that. Okay, one diagonal is the perpendicular bisector of the other. What does that mean? That means that AC is a diagonal, BD is a diagonal. So that means that AC not only is perpendicular with BD, but it cuts BD in half perfectly. So the length from B to E and the length from D to E are the same, and that's written right here. Okay, so AC is perpendicular to BD, and BE is equal to ED. So that's the special property of a kite. Now let's look here at trapezoids. Okay, so trapezoid is a quadrilateral, 4 sides, with exactly one pair of parallel sides, right? The bases we know are parallel. The length of the midsegment is the average of the lengths of the two bases. We know that, right? So that's my B1 plus B2 over 2 equals M. And then it says a trapezoid with congruent legs is an isosceles trapezoid. Okay, and an isosceles trapezoid, the base angles are the same. So the two bottom angles are the same, the two top angles are the same, and then these side lengths are the same. And then don't forget that your midsegment, AB, is also parallel to your bases. So lots of properties going on, but I think when we start to use them in problems, you'll see that it's really not as bad. So let's go back to 6.2 and we can start looking at some examples and see how do we use these properties. All right, so let's start here with example 1. Example 1 says, how are the diagonals of a kite related? So let's look at the diagonals. So I'm going to draw these, and keeping in mind that I'm not the best artist, right? So there's one diagonal, and there is the other. Perfect. So how are these diagonals related? So the first thing that we can say is that they are perpendicular. Okay, they are perpendicular. Remember the symbol for perpendicular is that upside down capital T. So that tells me right now that they cross at 90 degrees because they are perpendicular. The other way that they're related is the longer diagonal. The longer diagonal bisects. Remember what that word bisects means, right? Bi is 2. So bisect is cut in half, cut into 2. So the longer diagonal bisects the shorter diagonal. So what that means is the shorter diagonal is cut in half perfectly. So that tells me that this length is the same as this length. Okay. So then when we're looking here on the try it, it says, what is the measure of angle AXB? Okay, so you're going to figure out what is the measure of this angle, A to X to B. Then it says if AX is 3.8, what is AC? So you're going to see if you can do that. And then the last one says if B to D, right? Yeah, B to D is 10, does B to X equal 5? And then it says explain. Okay, so you guys are going to try these 3. Really just pause the video, think about it for a second, see what you come up with, and then when you're ready to go over it, hit play and we'll go over it. All right, so let's look at this. So first thing it says, what is the measure of A to X to B? So that is this angle right here. And because this is a kite, we should know that A to X to B is 90 degrees. So we can say that angle AXB is equal to 90 degrees, just like that, okay? The next part says if AX is 3.8, so this is 3.8, what is the distance from A to C? So what is this total distance? Okay, well, if this is a kite, which it is, this line from A to C is cut in half. So if AX is 3.8, then that means that CX is also 3.8. So then I can find what the total distance is by just adding those together. Okay, so line segment AC is equal to 3.8 plus 3.8 is 7.6. Okay, and then I'm going to kind of get rid of these just so it's a little bit easier to see. Okay, and then the last question says if the whole distance from B to D is 10, so this guy right here is 10, does that mean that this right here is 5? Right, half. And I know that from looking at the photo, we're just like, no, it doesn't, right? One, you can't always trust the photo. Always assume that I drew it and I can't draw. But also in this case, you would be right? So AC is cut in half, but BD is not bisected. It's not cut in half at all. So BX is not 5. So no, AC does not bisect. So AC does not bisect BD, meaning BD is not cut in half at all. So B to D can be 10, but that doesn't tell us anything about what B to X is or what D to X is. There, with the information I'm given right now, I would not be able to find that for you. All right, let's move on to our second example. Okay, so we're going to keep looking at the diagonals of a kite. All right, let's start with A. First of all, it says quadrilateral PQRS is a kite. So we know it's a kite. And the diagonals are Q to S and P to R. So the first thing is, what is the measure of angle 1? Right here, this guy right here. And hopefully that's really quick because we see that it's at the intersection of the two diagonals. So the measure of angle 1 is 90 degrees. I'll just draw on the little square. There we go. Okay. Then it says, what's the measure of angle 2? That one might be a little bit trickier. I'm going to draw this. Right? This is 90. This is 35. And this is 2. And I don't like it being called 2. Let's call it x instead. So I should know that the three angles of a triangle add to 180 degrees. So that tells me that x plus 90 plus 35 equals 180 degrees. Okay, now this hopefully is something that I can just solve, right? X plus, well, 90 plus 35, so I get x plus 90 plus 35 is 125 equals 180. We can subtract 125, subtract 125, and I get x is equal to 55. So that tells me that the measure of angle 2 is 55 degrees. So sometimes it's helpful if you take what it is you're trying to find and draw it outside of the diagram that's already been given to you. The last question says, what is the measure of angle 3, which is right here. Well, just so we know, right, kites are symmetrical. So if I were to fold them in half, they would line up perfectly. So if I folded this in half along this line, it would line up perfectly. So that tells me that angle 3 is the same thing as angle QPT here. So hopefully that's pretty quick as well, where I get that the measure of angle 3 is 35 degrees. It is the same as angle QPT. All right, you guys have a try it now. So I'm going to go ahead and get rid of this. Let's scroll down and look at the try it. Here's our try it. We're given this quadrilateral. We're told it's a kite. And we want to know what is the measure of angle 1 and what is the measure of angle 2. So go ahead and hit pause on the video, give it a shot, and then when you're ready to check your work, you can hit play. All right, so quadrilateral WXYZ is a kite. I want to know what is the measure of angle 1. So let's look at this. Again, sometimes it's helpful to draw things in, but this triangle is already pretty big. Okay, so I'm just going to look at this triangle right here. And I know that this is a right angle because of the kite, the diagonals are always perpendicular. Okay, so this is 32, this is 90, and then this, let's call it x. Okay, and so I can set up that equation again. X plus 90 plus 32 equals 180. I can combine the 90 and 32 to get 122. Subtract 122 to both sides. And I'm going to get that x is 58 degrees. So that tells me that the measure of angle 1 is 58. Okay. I'm going to go ahead and get rid of this, and I'm just going to fill that in now that we know what that is. So this is 58. Okay. The next thing is, what is the measure of angle 2? All right, so again, kites are symmetrical, right? They can be folded in half directly down this long diagonal, in this case, which is XZ. And so that tells me that this angle, WXZ, is the same as YXZ. These two angles are the same. So if this angle is 32, then this one is also going to be 32. So that, hopefully we found out the measure of angle 2 is 32 degrees. So hopefully not too bad here. What we're going to do now is we're going to switch over and we're going to look at isosceles trapezoids and some of the special properties that happen in isosceles trapezoids. Okay, so let's start with a real world example of how we can use these isosceles trapezoids. So Kaio is designing a trapezoid-shaped roof. In order for the roof to be symmetric, the overlapping triangles D to A to B and A to D to C must be congruent. Will the roof be symmetric? So I think the easiest way here is to draw these triangles separate. And again, I tell you guys this all the time, right? I said draw the triangles separate. So this, let's call this is D, here's A, and here is B. Okay, so that is this triangle, DAB. And then I'm going to draw the other triangle, something like this, where this is C, this is D, and this is A. So again, not perfect, but at least we can see these two separate triangles. And then let's go through and write down what we know. So I know that AB is congruent to CD because they tell us, right? These little tick marks right here, they tell us. Okay. Also, I know that the same side is used in both of these. So AD, right, in the left triangle is the same length as AD in the right triangle. So these are the same because they're the same side. They're literally overlapping. And then the last thing that I know is the same in both of these triangles is, in this case, B to A to D, this angle right here, B to A to D, is the same angle that is in C to D to A, this guy right here. Okay, so the question is, and the reason, let me show you the reason why I can say that. If I extend this up and make this, oops, a little bit more, and make this a triangle. Okay, let's just say that I do that. And I extend this up and make this a triangle. Because this side length and this side length are the same, right? They are the same. That means that this angle and this angle are the same because it's an isosceles triangle, okay? And so all I'm doing then is I'm just taking the upper part of the isosceles triangle and cutting it and making it an isosceles trapezoid. So that's how I'm able to know that angle A and angle D are the same. So now looking at this, I want to know, are these two triangles the same? And they are, and I can say that triangle DAB is congruent to triangle ADC by side angle side. So we have to kind of think back, side angle side congruency. Think back, I have a side, excuse me, I have two sides and the angle between the two sides. So the angle is between the two sides. Okay, so since these two triangles are congruent by side angle side, the roof will be symmetric. So the roof will be symmetric. So remember that when we have an isosceles trapezoid, okay, so an isosceles trapezoid, these two base angles at the bottom are always going to be the same. And the two base angles at the top are always going to be the same. They're not the same to, like, right? All four of them are not the same. But angle B and C are the same, and angle A and D are the same. Okay? So we have two triads here. Might take a little bit of brain power. So that's, something that we'll have to look into. Okay? Remember that what we talked about in our last lesson, 6-1, about the sum, right? Can I add up all four sides of a quadrilateral, or excuse me, all four angles of a quadrilateral? What do they add to? So that's going to be a huge hint for you right here, okay? So the sum of a four-sided shape, think of a square, right, is 360 degrees. So if I know that this is 135, what else do I know is 135? And do I know what P and S is? So I want you to try A and B here. Just give it a shot, hit pause on the video, and then when you're ready to go over it, go ahead and hit play, and then we'll work through it. All right, so hopefully you guys tried this, and let's go over it. So I know the angle R is 135. And because this is an isosceles trapezoid, right? So I can draw in those tick marks. Because it's an isosceles trapezoid, I know that Q is also 135. And I don't know anything about P, so I can call that one S, but I do know that, or X, excuse me, but I do know that S is also equivalent to P, so those are both X. And I know that if I add up all four of these, it should equal 360. So we can go ahead and do that, right? X plus 135 plus 135 equals 360. Okay, and I don't know why my handwriting is just falling, but that's okay. 135 times 2 is 270, so I have x plus x, which is 2x. 135 plus 135 is 270, and that equals 360. Okay, so I'm going to subtract 270 from both sides. And I get 2x is equal to 90. Divide by 2, divide by 2, and I get x is equal to 45. So that tells me that the measure of angle P is 45 degrees. And if the measure of angle P is 45, then the measure of angle Q is also 45. And then the only other one I didn't know was Q, which I found pretty easily because it was the same as the other base angle. And that's it. Okay, so we're just using then our information from 6-1 on, okay, what is the sum of all four angles, interior angles of that trapezoid. The last one here is I'm given the ST and RU are parallel. So this is a isosceles trapezoid. What is the measure of TUR? So this is what I'm trying to find right here. What is the measure of this? The only information I'm given is that this is 147. Okay, well, if that's 147, I should be able to find this one, right? Because they are supplementary. They add to 180, right? So if I do 180 minus 47, that tells me that this is 133. Well, if that is 133, the other base angle, right, on the same base has to be the same because it's an isosceles trapezoid. So this is also 133. So the measure of angle TUR is equal to 133 degrees. So just kind of like piecing in those puzzles or those missing puzzle pieces as you go. All right, let's go on to the next example. Example 4 here is all about this transmission tower. So it says all horizontal beams of the high voltage transmission tower are parallel to the ground, right? So what that tells me is this is parallel, and this is parallel. What that means is that I have two trapezoids here. That's all that's saying. Here's one trapezoid, right? And then here's the other trapezoid. There. Okay. Okay, so I'm gonna actually scoot down just a little bit more. There we go. The top section is an isosceles trapezoid, so that also means that these guys are the same length, which we kind of knew because they were both labeled 10. The center section is an isosceles trapezoid, so that means this side and this side are the same, which again we knew because they were both labeled 14. So it says if the measure of angle 1 is 138, what is the measure of angle 2? And here's angle 2 down here. So again, sometimes, at least for me, I find it's easier if I draw it out separately, right? So this is 138. And this is an isosceles trapezoid. So I know if that's 138, then that means that this is also 138. And I don't know what this is, and I don't know what this is, but I do know that the sum of a four-sided figure, right, if I add up all the interior angles, I will get 360. So I can do x plus 138 plus 138 equals 360. Okay, and then just start combining like terms. So x and x is 2x. 138 and 138 is 276. And that equals 360. Okay, I'm going to subtract that 276 to the other side. That leaves me 2x is equal to 84. Divide by 2, divide by 2. I get x is equal to 42 degrees. So that tells me that the measure of angle 2 is equal to 42 degrees. Just like that. Okay, the second part of this problem, and I'm actually going to erase this and scroll down just so we have enough room here. There we go. So the second part of this problem says one cross support in the center of the tower measures 4c plus 3, so here's that one, and the other one is 6c minus 5. What is the length of each cross support? Okay, so in an isosceles trapezoid, the diagonals are congruent. So they are the same length. So if the diagonal of one is 4c plus 3, and the diagonal of the other is 6c minus 5, they are equal to each other. So we can set them equal. 4c plus 3 equals 6c minus 5. I can set them equal to each other. I'm going to subtract 4c, and I get 3 is equal to 2c minus 5. Add 5, running out of room, right? 8 is equal to 2c, divide by 2, divide by 2, 4 equals c. Okay, and that's interesting, but that's not what it's asking me to find. It's asking me what is the length of each cross support. So I want to know what is the length from here all the way down to here. So what we're going to do is pick a side. I drew the 4c plus 3, so we'll do that one. 4c plus 3. And I'm going to plug in my value for c. So 4 times 4 plus 3. I get 16 plus 3, which is 19. Okay, so the cross support, is 19, and then don't forget units. In this case, it's feet. And I know that from the diagrams, right? This is 14 feet, 14 feet. So that tells me that my units is in feet. All right, you guys have a try it here, and then it's very, very similar to part B. Go ahead and pause the video, give it a shot, and then we'll look at it here in a second. Okay, so this try it is very, very similar. I'm told this is an isosceles trapezoid, so NO and MP are the same length. And I'm given that the diagonals are a plus 13 and 2a minus 1. And in this case, it says, what is the value of a? Well, we just have to remember that the diagonals of an isosceles trapezoid are the same. So a plus 13 is the same as 2a minus 1. And in this case, it's just asking what is the value of a. So I just have to solve for a. Okay, so I'm going to subtract a. So I get 13 is equal to a minus 1. Add 1, add 1, and I get 14 equals a. And I don't need to go and plug it back in because it's just asking what is the value of a. If it was asking me how long is MO, okay, then I would have to go and plug it back in. Okay, example 5 is pretty much the exact same thing. I want you guys to try this one yourself again. So consider it a try it. Okay, go ahead and pause the video and try this out, and then when you're ready to go over example 5, we'll do it together. Okay, so hopefully you guys got this. It was exactly the same as the other two that we just did. BD here was 5x plus 1, and AC is 3x plus 19. And the diagonals of a isosceles trapezoid are equal. So I'm going to set them equal to each other. So 5x plus 1 equals 3x plus 19. And I'm going to solve. So let's minus 3x, minus 3x. So I'm left with 2x plus 1 equals 19. I'm going to subtract 1 from both sides, and I get 2x equals 18. Divided by 2 divided by 2, x equals 9. Great. But it's asking what are the lengths of the diagonal. So I'm actually going to have to go and plug this back in. And you can plug it back into either one. It doesn't matter. I'm going to use 5x plus 1. So I have 5 times 9 plus 1. 5 times 9 is 45. Plus 1 is 46. So the diagonals, right, are both 46. And I don't know what the unit is, so I'm just going to write 46 units. Right? They didn't tell me whether it was feet or inches or centimeters or miles or whatever, right? I don't know. So when I don't know, I just write units. Okay, the last example, example 6, we're going to look at the mid-segment theorem. So again, the mid-segment theorem is when we have that fun little formula, B1 plus B2 divided by 2 equals M. Right? So if I take my two bases and divide by 2, it's going to give me the length of the mid-segment. In this case, I need to actually look to make sure it's a mid-segment. So let's read the problem and see what they want me to find and all that kind of stuff. So it says Paxton makes trapezoidal handbags for her friends. So this is a trapezoid. She stitches decorative trim along the top, the middle, and the bottom on both sides of the handbags. How much trim does she need for 3 handbags? Okay. So when we look here, I know that this line right here is the mid-segment. And I know that because this length is 2 inches and this length is 2 inches, right? And this is 2 inches and this is 2 inches. So I know that that line of trim in the middle is the mid-segment. So all I have to do now is I know what base 1 is, I know what base 2 is, so I know how much trim she needs along the bottom. I know how much trim she needs along the top. I just need to know how much trim she needs in the middle. So I'm going to use my formula. Where base 1, again, it doesn't matter. It can be 6 or it can be 9. I'm going to call it 6. I'm going to call this one base 1. And I'm going to call this one base 2. But it doesn't matter. You could switch that. Okay? So I have 6, which is base 1, plus 9, which is base 2. I'm following this equation. Divided by 2 equals M. Well, 6 plus 9 is 15. 15 divided by 2 is 7.5. So 7.5 inches equals M. And I know it's inches because that's the unit in the image. So this right here is 7.5 inches. So now let's look. Let's see how much trim she needs for one handbag. And then we can just multiply it by 3. Okay, so the front of the purse, of the handbag, is 9 inches along the bottom, plus 7.5 inches in the middle, plus 6 inches on the top. So if I add all that up, that gets me 22.5 inches. So for the whole front side of the handbag, I'm going to need 22.5 inches of trim. Okay? Then the back should be the same thing, right? So 6 inches along the top, 7.5 inches in the middle, 9 inches on the bottom. So the back should also be 22.5 inches. Okay, so that means that the total for one handbag, the total for one bag is 22.5 plus 22.5, which is 45 inches. So she will need 45 inches of trim for one handbag. But the question is asking how much trim does she need for 3 handbags. So I'm just going to have to multiply that by 3. So the total for 3 bags is just 45 times 3, which is 135 inches. And that is what they are trying to get after here. So really the only new math that we did here was the mid-segment theorem, where I'm just saying I took the top base plus the bottom base divided by 2, and that got me the mid-segment. We're going to do one more together, and then you guys are going to try one on your own. Okay, so here I have trapezoid JKLM. What is the length of K to L? So that's what I'm curious on, right? So I'm going to call this one B1, I'm going to call this one B2. But again, it doesn't matter, you could have switched that up, okay? So I'm going to look, I don't know what B1 is, so again, I'm going to write down my formula. B1 plus B2 divided by 2 is equal to M, where M is the midpoint, right here. Well, I know what M is. M is 25, okay? And I kind of know what B2 is. B2 is 4/5 times XY. Well, XY, this right here, XY is 25 because it's right here, right? So we can find out, let's find out what JM is. So JM is, let's write it. So JM is equal to 4/5 times 25. So we kind of think about how do we multiply fractions, right? So I need to make 25 a fraction, and I'm going to do that by putting it over 1. And then we multiply fractions straight across. So 4 times 25 is 100. 5 times 1 is 5. And then 100 divided by 5 is 20. So that tells me that JM is 20 meters. So now I know what M is. I know what B2 is. I just need to find B1. So I'm going to start plugging things in. I don't know what B1 is. B2 I just found out was 20. If I divide that by 2, I get M, which is 25. And we're just going to solve for B1. There's really nothing I can do except multiply 2 to both sides here. And that gets rid of the fraction. These 2's cancel. So I get B1 plus 20 equals 25 times 2, which is 50. I'm going to subtract 20, subtract 20, and I get B1 is equal to 30, which is what I was trying to find. What is the length of KL? It's 30 meters. So K to L is 30 meters. So it's just your one base plus your other base divided by 2 gets you your mid-segment. So the last one to try here, it says the manager of a trapezoidal dog park wants to build a fence to separate the park into a small dog and large dog area. What is the length of the new fence? So this right here, this is what I'm trying to find. What is the length of the fence? Go ahead and hit pause on the video, and then when you're ready to check your work, hit play. All right, so hopefully we're feeling confident on this last problem here. Again, you can label this if it helps you, B1 and B2, right? Those are your bases. Remember, your bases are always the 2 sides that are parallel to each other. Okay, so I'm going to take my formula, B1 plus B2 divided by 2 equals M. And I'm going to solve. So in this case, B1 is 70 plus B2 is 120 divided by 2. And I'm just going to simplify. 70 plus 120 is 190 divided by 2 gets me 95 feet. So this fence will be 95 feet long. So what is the length of the new fence? Right, the new fence. Whenever we have a word problem, don't forget to answer in a sentence form. So So the new fence will be 95 feet long. All right, guys, that's it for 6-2. If you have any questions at all, make sure you reach out, and we'll see you on next video.